This question is a little different than the last two questions. The last two questions were simultaneous move games, and this is asking if B moves first, what military strength do they choose? So we're going to look at the difference between a first mover game and a simultaneous move game. First, let's start off by writing our total value functions for each country. Now, I've defined total value as the expected benefit of non-war military functions less the expected war losses less military spending. This is what he told us to maximize, so I want to just define this as total value. For A, this is the total value, and for B, this is the total value. Now, since B is the first mover, we want to start from A's total value function. This is because we want to get A's reaction function. Remember, a reaction function tells us how country A will respond to any given choice by country B. So if country B is moving first, and we're assuming they all know all this information, so country B could easily find A's reaction function, well then country B would want to find A's reaction function and use that information to make the best decision about picking the strength of their military. So what I mean by this is they want to find A's reaction function and plug that function into their total value function, into B's total value function. So first let's find A's reaction function. Well, we can simplify this a little bit. We know that VA is equal to 1,000. It was given to us in the problem. We can also multiply that 0.01 times the 1,000 and just simplify it down to the minus 10 there. Now we're ready to take the derivative of this thing with respect to SA. The 9.9 SA just becomes 9.9. We leave the 10 outside the brackets, and we do the derivative inside the brackets. So we have SB times 1 minus SA, and we want to take the derivative of that with respect to SA. Well, we distribute through the SB, so it's SB minus SB SA. So that derivative is just simply minus SB, because the SA drops out, and the SB by itself drops out. And then we have minus 40 SA when we take the derivative of that last part. We can set this equal to 0 and start to simplify, and we find that SA's reaction function is equal to 0.2475 plus 0.25 SB. So country A will respond to any given choice by country B in this fashion. Well, now that we've solved for A's reaction function, we need to start at B's total value function. And the idea here is we're going to plug what we found for SA into that total value function. So we do that, and we know that VB is equal to 1,100. We can simplify that down. The 1,100 times the 0.01, all that's on the outside of brackets. We can just put that in the front as the negative 11. Now we're ready to take the derivative of this, and this is very tricky, so be careful with the derivative. We want to keep that 11 outside the brackets, and we want to look at just that middle part. We have two sets of parentheses, so we're going to use the product rule, which says first times the derivative of second plus second times the derivative of first. The first thing is 0.2475 plus 0.25 SB. The derivative of the second thing is just negative 1. The second thing is 1 minus SB, and the derivative of the first thing is 0.25. So now that we've done that derivative, we want to simplify inside the brackets. We're not going to distribute through that negative 11 because that just is going to confuse things. So first we want to simplify inside the brackets as best as we can. We distribute through that negative 1, and we distribute through that 0.25. We can combine like terms within the brackets, and now it's easy enough to distribute through that negative 11. We do that. With a little bit of algebra, we see that we're going to be actually able to solve for SB because we only had one variable after all. We see that SB is equal to 0.2861594. Now finding SA is easy. We already found A's reaction function, so we just plug in what we just found for SB into that function that said SA is equal to 0.2475 plus 0.25 SB. When we do that, we find SA is equal to 0.3190399. Now this question, the problem set question, only asks us to find SB. I went ahead and found SA to show you how we would find SA. But then after the problem set question's over, he mentions that you want to know how this is different than a simultaneous move game. Well, let's take a look. The simultaneous move game, we would start with the total value function of B, and we'd find B's reaction function, just like we found A's reaction function. We go through all the math, and we see that B's reaction function, once we divide through by 40, is SB is equal to 0.2475 plus 0.275 SA. Now that we have both reaction functions in the simultaneous move game, we're going to use substitution to solve for each variable. So we plug in what we found for SA into the reaction function of B. We can do some algebra and we can solve for SB is equal to 0.3388591. Solving for SA is easy. We just plug in what we found for SB into A's reaction function, and we solve for SA is equal to 0.3322148. So let's look at the graph of these reaction functions when it's a simultaneous move game. Here are the two reaction functions, and the graph looks like this. Remember, they're upward sloping reaction functions. The upward sloping, that tells us a couple things about this kind of game. The more player A chooses, the more player B chooses. That's what the upward sloping reaction functions tell us. So the bigger the army B has, A is going to want to have a bigger army as well. Well, in the simultaneous move game, we see that the Nash equilibrium happens at the intersection of those two lines, and we find that SA and SB equal these. So what's different about the first mover game? Well, let's take a look. The first mover game, we have A's reaction function, but we don't really have B's reaction function. Instead, we just plugged in A's reaction function and found what country B will produce, and that was 0.2861594. So this is the simultaneous move game Nash Equilibrium. Let's take a look at where the first mover game compares. We see that we're going to choose less if we're country B. We're going to choose a smaller strength army, and the way we find how much country A is going to choose is we go up from our choice of B, we hit the reaction function of A, and we go over to the y-axis, and we see that A will choose also a smaller strength army. So when there's a first mover in this game, both countries are going to choose a smaller army, or have a weaker army, I should say.